My name is Jasmine Elliott, and I'll be going over 6.2 and 6.3, addition and subtraction of fractions, and multiplication and division of fractions. Okay, so we're starting off with 6.2, addition and subtraction. The sum of 2 eighths plus 3 eighths equals shown in the models below. So here we have a fraction of 8 full pieces, and 3 of those are shaded in. So if 3 of those are shaded in out of those eighths, that give us 3 eighths. We are adding that to another fraction circle with 8 pieces. 2 of those are shaded in. If 2 of those are shaded in out of that 8, that gives us 2 eighths. So when you add 3 plus 2, you get 5. Knowing that they're both out of 8, you get 5 eighths. So here you have 5 pieces shaded in, the total of 8. Another way to explain that is if you do a number line. You have the number line going from 0, 1 eighths, 2 eighths, 3 eighths, 4 eighths, 5 eighths, 6 eighths, 7 eighths, all the way to 8 eighths, which is also equivalent to 1 because any number over itself is 1. So you start at 0 and you're adding 3 eighths and 2 eighths. So you move over a spot of 3 eighths, which you'll stop right here, 3 eighths, and then you're adding 2 eighths. So they're already in eighths, so all you have to do is count 1, 2. So then you make your arrow jump over another 2 eighths, which lands at 5 eighths. So what you're saying is if you add 3 eighths and then jump over 2 eighths more spots, so adding another 2 eighths, that gives you 5 eighths. So shown in the models above, it shows that the sums of the numerator over a common denominator is the answer to how you add the fractions. Okay, to add a fraction with unlike denominators, meaning that the two bottom numbers are different, you have to find a common denominator. It is easiest to find a common denominator dealing with the least common multiple, which is what number can these two numbers go in? What is the lowest number? So for this certain equation, that number would be 12. So to get these numbers, or these fractions to be the same, common denominator, we'll have 1/4. To get 12, you have to multiply 3. And whenever you do to a bottom of a fraction, you have to do to the top. So you need to multiply 3 over 3, which will give us 3/12. Same thing for the 2/3, except we have to multiply by 4 over 4 to get us 8/12. So now we have 3/12 plus 8/12. And anytime you are adding or subtracting an equation, the denominators always have to be common. It has to be a common denominator. So now that the denominators are common, it is easiest for us to just go ahead and solve the equation. So 8 plus 3 is 11. The denominator never changed when adding and subtracting. So that will be 12. So the answer to this equation, and it can't be simplified, will be 11 over 12. To show that, we can have 1/4. So we'll have 1/4 shaded in. And then we will have 2/3. And we would need to be adding this together. Given that it's not the same base number, it is still hard because there is no common denominator between the two, shown like this. So we have to do what we did earlier, make it a common denominator. So now we have to find the common 1/4 to the common denominator, which will give us 3/12. So now we have to find what that will look like. So let's draw this up here. Alrighty, so we need to make this into 12ths. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 1/4 is equal to 3/12. As you see below, the same amount of space shaded in, just smaller units of it. So 3/12. And then down here, we have our 8/12. So we did the same thing. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we have 8 of those shaded in. 1, 2, 3, 4, 5, 6, 7, 8. Which is the equivalent to 2/3 because they have the same amount of space shaded in. So once again, when we add those together, we get the total of 11/12. 1, 2, 3, 4, 5, 6, 7, 8, 9. So all of this gives us a total of 11/12. Okay, so the same procedure can be followed to add every two fractions. A over B plus C over D is A over B plus C over D, which is equal to A times B, D, over B times D, plus C times B over D times B, which equals AD plus BC over BD. So basically you're adding the numerators over the common denominator, always. And that is after you find the common denominator. Okay, so now we're doing some examples. For the first example, we have 1/2 plus 3/8. So we need to get these to have common denominators. If 1/2 is 1/2, then we know 4 is half of 8, which makes 4/8 also 1/2. If you didn't know that, you could also just find the common denominator. What times 2 equals 8? 4. So you multiply this by 4 over 4, which is equal to 4/8. So now we have common denominators, so we can add the two equations. 4/8 plus 3/8 equals 7/8. And that will give us the final answer. To demonstrate that, for someone who may not understand, we make this out of 8. And then we will shade in to find the answer. So we have 1/2. You will not just shade in 2. You will have to shade in what the number is out of 8. So you will shade in 4 since it is 4/8. And here you will shade in 3 since it is 3/8. So now we add that together. If this is already 4 and this is 3, we're adding 3. So we can add 3 right here. That only leaves 1 blank. So 8 minus 1 is 7. So we have 7 shaded in. So that would give us a total of 7/8. And that is how we show that answer. Moving on to the second example, we have 3/8 plus -7 over 12. Do not let the negative confuse you. If you want to, you can take out the negative. You can add it back on if it does confuse you. So first we have 3/8. We need to find the common denominator between 8 and 12. The least common multiple between the two will be 24. So we have 3/8 and -7 over 12. So starting with 3/8, we're trying to get the denominator to be 24. So what times 8 equals 24? That will give us 3. So we're multiplying 3 over 3, which gives us 9/24. And don't forget, whatever you do to the bottom, you have to do to the top. So we have the denominator of 24 here. Now we need to work on -7/12. So multiplying that by 2 over 2, because that is what gets us 24 at the denominator, we'll have -14 over 24. So now we can add the two equations. 9 over 24 plus -14 over 24. When you're adding a negative number and a positive number, you're basically subtracting. So since -14 is negative and 9 is positive and -14 is greater, 9 is being taken away to make -14 as closest to 0 as possible. So basically you're doing 14 minus 9 and adding a negative sign in front of it, because the number will still be negative since 9 is not greater than 14. So then we will get -5 over 24. And that will be our final answer here. To explain this example on a number line of how 9 over 24 plus -14 over 24 equals -5 over 24, you just start here. So we start with 9 over 24. So we start at 0 and we jump to 9 over 24. But now we have plus -14 over 24. We're just looking at the numerators here because the denominators always stay the same, and we know that these are out of 24, so we don't have to look in between anything. So negative, meaning left, means we have to go back 14. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Going back 14 spots, That will bring us to negative 5. And since this is out of 24, it will bring us to negative 5 over 24. And that is how we get the answer of negative 5 over 24. Okay, so with some more examples, we have example C. 3 over 4 plus 5 over 6 plus 2 over 3. 3 over 4 plus 5 over 6 are in parentheses. So we have something called PEMDAS. And most people know it as please excuse my dear Aunt Sally. So P stands for parentheses, E stands for exponents, M stands for multiplication, D stands for division, A stands for addition, S stands for subtraction. But what people get confused about PEMDAS is that they think that whatever order these are in means how you do it in an equation, but that is not the case. Whichever one comes first in an equation is which one you do first. Besides these two, whichever one comes first between these two is what you do in an equation, and it does matter, but that is something that we will talk about later on. So now we have 3 over 4 plus 5 over 6, and we know that we have to do the parentheses first. So we move over here to the parentheses, trying to find a common denominator between 4 and 6. So we will do the least common multiple, which will be 12. Multiplying 3 over 4 by 3 over 3 to get 12 as a denominator, which will give us 9/12, and 2 over 2 to get 12 as a denominator, which will give us 10/12. So now we have these two. We can add those together and get 19 over 12. So then we'll move on, and we're adding that to 2/3. We need to get 2/3 to have the denominator of 12, which will multiply by 4 over 4, which will get 19 over 12 plus 8 over 12. So now all we have to do is add that together, and that will give us 27 over 12. But we always need to make sure if we can simplify that we simplify. So 27 over 12 can be divided by 3 over 3, which will be giving us our correct and simplified answer, 9 over 4. Moving on to example D. You see that the fractions are the same from example C, but they're moved around. Do we know if that will change the answer? Let's find out. So we start off with the parentheses. We have 5 over 6 plus 2 over 3. Trying to get these to be common denominators, we'll multiply 5 over 6, 2 over 3. 6 can stay where it's at because that is the least common multiple between the two. So multiplying that over 1 over 1, 5 over 6. That can stay by itself. 2 over 3 can be multiplied by 2 over 2 to get 4 6. So now we have 5 6 plus 4 6, which gives us 9 6. So now we're trying to add 9 6 to 3/4. And then we have to find the least common multiple, which will be 12. So 9 over 6 times 2 over 2 is giving us 18/12. And 3 over 4 times 3 over 3 is giving us 9/12. And when we add those two together, that gives us 27/12, which we got over here. So we know to divide that and simplify it by 3 over 3, and that will give us the correct answer and simplified answer of 9/4, just like it did in that equation. Moving on to proper fractions and mixed numbers, the sum of a natural number and a positive fraction gives us a mixed number. An example is 2 plus 3/4, which equals 2 3/4, read as 2 3/4. You have to make sure you have that and, because if you go 2 plus 3/4, we know that that is 2 3/4. But if you just write 2 3/4 and not the plus, we can read that as 2 times 3/4, which multiplied out can give us 6/4. And that's not what we're doing with this addition mixed number. Okay, so mixed numbers can always be written into standard form A over B. Example, 2 3/4 equals 8 over 4 plus 3 over 4, which gives us 11 over 4. And we know that because 8 plus 3 is 11, and the denominator is never changed, so that will stay 4. We know that 2 is equivalent to 8 over 4 because 8 divided by 4 is 2. 4 divided by 8 is 1/2, but 8 divided by 4 is 2. Easier in another way we could do that would be 2 3/4. So if you multiply the denominator by the whole number, that will give us 8. And then you add the numerator, that gives us 11 over 4. And that will be for every mixed number. That could be an easier and simpler way to put that into standard form. We know that 2 over 1 also multiplied by 4 over 4 to get this common denominator is 8 over 4. And it's not just because that 8 over 4 is 2, but also because when you give them common denominators, that will still help you find the mixed number. So now moving on to the visual prospect of it. You have 2, I wrote too many squares, 2 and 3/4. And then you'll have 11/4. So if you look at them closely, you realize that they are all shaded in the same exact amount. So these two fractions are equivalent. They are both 11/4 and 2 or 3/4. They are the same thing, just written 2 different ways. Okay, so now moving on, a fraction a over b for which 0 is less than or equal to the absolute value of a, which is less than b, is called a proper fraction. For example, 2/3 is a proper fraction, because if you take the absolute value of 2, that will give us 2, which is less than b, which is 3. So that is a proper fraction. But 3/2, -8/5, 6/6, those are not proper fractions. Fractions that are not proper fractions are common to be written as mixed numbers. Example, you have 439 over 19. You do the math, and you get 23 and 2/19. Okay, so moving on, we're going to talk about the subtraction of fractions. So an example that we'll be using to show off the next 3 models of subtraction is 7 over 6 minus 3 over 6. So just like addition, the common denominators have to be common. The denominators have to be common to do the equation. So these are already common, so all we have to do is subtract 3 from 7. 7 minus 3 gives us 4. The denominator stays the same, which is all over 6. And that will be our answer if you don't simplify it. If you do simplify it, that is 2/3. So the first model that we'll talk about is the takeaway model. So this model, we will begin with 7/6. So all of these will be shaded in because that is 6. And then we'll draw out another one. And then just shade in 1 to make that 7/6. And then we will remove away 3/6 of that 7/6 since we're subtracting. So 1, 2, 3, which leaves us 4/6. So shaded in left, all we have is 4 of the 6. So that will be our answer. And if we have to simplify that, you would divide 2 over 2 and get 2/3 as your answer, because that is the greatest common factor between the two. Okay, so another model will be our measurement model, which is with the number line. So we already have these in 6, since that was our denominator. We had 7/6 minus 3/6, which equals to 4/6, as we found out. So we have these in 6. So we have these 1/6 through 11/6. So we're starting at 0, and we're going up to 7/6, because that is what we begin with. 7/6. We need to take away 3/6 of that 7/6. So jump back 3 spots. 1, 2, 3. We're at 4/6. And since we at 4/6, that is what our answer will be. The arrows will point towards the beginning. And when you're subtracting and you're giving examples, that is where the arrows go. This model is showing us how addition and subtraction are connected, basically. So we have the missing added model. We are giving 7/6 and 3/6, which we figure out, take away 3. That is giving us 4/6. So we know if 3/6 plus 4/6 is equal to 7/6, then 7/6 minus 3/6 must equal 4/6. doing a couple examples before we move on, we have 4 over 5 minus 2 over 3. So we know that these have to be common denominators because with addition and subtraction, once again, the denominators have to be common to do anything. So starting off, find the least common multiple, which will be 15. We will multiply 4 over 5 by 3 over 3 to give us the denominator 15, which will give us 12 15ths. And then with 2/3, we'll multiply 5 over 5, which will give us 10 15ths. So then we have 12 15ths minus 10 15ths, which is equal to 2 15ths. And that is our total answer, 2 15ths. So now to show how we got 2 15ths, we draw out a number line. We have 0, 1 15th, 2 15ths, all the way to 12 15ths, and then you have the full 15 over 15, which is 1, because any number over itself is 1. So starting at 0 and going over to 12 15ths, because that is where we go, we have to take away 10 15ths. When we count back 10 spots, taking away 10 15ths, that lands us at 2 15ths. And that is the final answer. Okay, so moving on to another example, we have 103 over 24 minus negative 35 over 16. So even though this may seem like a big number and there is a negative in here, that is not the first thing we need to worry about. The first thing we need to worry about is finding a common denominator. So the least common multiple between the two will give us 48. So we need to figure out how to get 24 to 48. So multiply by 2, that will give us 48 at the denominator and 206 at the numerator. And then we have negative 35 over 16 times 3 over 3, which will give us 48 at the denominator and 105, negative 105 at the numerator. So when you are subtracting a negative, you're basically adding it. So 103 or 206 minus negative 105 will basically give us a positive number. These two negatives turn into one positive. So just think about it like you're overlapping each one. So we'll get 311 as the numerator, and we'll get 48 as our denominator, and that will be our answer. Last but not least, we're going to talk about one more example. We have 4 1/4 minus 2 2/3. There are different ways you can go about this, but I'll show you one way first. So, like I said, you can multiply 4 by 4 and get 16, and then add the 1 and get 17 and have 17 over 4. And then you can go 3 times 2 and get 6 plus 2 and get 8 and have 8 over 3. So we need to get these two numbers as a common denominator. So multiplying this by 3 over 3, I'll get 51 over 12. And then multiplying this over 4 over 4, I will get 32 over 12. When I subtract the 2, I will get 19 over 12. And putting that into a mixed number, I will get 1 7/12. To figure out how to put this standard number into mixed number form, you just divide 12 into 19, which will be 1, because 12 can only go into 19 one time. And then 12 minus 19 minus 12 is 7, which will be a remainder of 7. So we know that 7 will be our numerator, 1 will be our whole number, and then the common denominator never changed, so that is how we got 1 7/12. We just talked about 6.2, addition and subtraction of fractions. Now we are talking about 6.3, multiplication and division of fractions. So we note that multiplication is easier than the addition and subtraction of fractions, given that we don't have to have a common denominator to start the equation. An example. 3 over 4 times 2 over 5, we just multiply the numerator, so 3 times 2 is 6, multiply the denominators, 4 times 5 is 20, and 6/20 will be our answer, of course. That is not simplified, so if you divided 2 over 2, that will give us 3/10, and that will be simplified, but regardless, that is our answer. So you just multiply the numerator and the denominator when multiplying. But to compute 3 over 4 divided by 2 over 5, we use something called invert and multiply rule. And that is one of the that we can use, which is one of the main rules that I use all the time when dividing to figure out the answer to the equation. So 3/4 divided by 2/5 can be written as 3/4 times 5/2. Now, division and multiplication have something in common, just like addition and subtraction do. They're partners. So if we multiply by the reciprocal of 2/5, which is the inverse fraction just flipped, you can get the answer of the whole equation, which will be 15/8. That can't be simplified. That is the final answer unless you just put it into a mixed number form. Okay, so multiplication of a fraction by an integer. Pizza was ordered for partying. All the partiers never finished the pizza. How much pizza was left over? So here we are multiplying 3 and 1/4. So addition and multiplication have something in common as well of subtraction and division. Everything is connected in some sort of kind of way. So here we're going to show how addition and multiplication are connected. So we're multiplying 3 and 1/4, which is nothing but 1/4 added 3 times. So 1/4 added 3 times. All the denominators are the same. All we have to do is add the numerator is equal to 3/4. That is our answer. And then to show that, how we just multiply it, 3/1, because any number over 1 is itself. So 3/1 times 1/4. We don't have to have common denominators. 3 times 1 is 3. 1 times 4 is 4. That is also 3/4. So that proves that the answer is correct. So to show it here, we just have 1/4, 1/4, 1/4 equal to 3/4. All these ones added up in one circle gives us 3/4. Okay, so here I am showing you examples of how I got the things that I did. So I'm going to show you how I got 3 times 3/8, how I got 9/8 of 3 times 3/8 in strips. So here we got 3/8 3 times because we're multiplying 3 by 3/8. So I also wrote it out for you. 3/1 is 3. So 3/1 times 3/8 is equal to 9/8. So here I have 3/8 written out 3 times. If you count the squares that is shaded in, that gives you 9. So we have the whole 8 filled in plus one more of another 8. So that gives you 3 3/8, which is also 9/8. 3 3/8 is just 3 times 3/8 is equal to 9/8. And it is shown by multiplying these 3/8 3 times and giving us the conclusion of the whole 9/8. So here I am showing you with a number line how 4 times 2/3 is equal to 8/3. I wrote it out. 4/1 times 2/3 is equal to 8/3, which it is. So we write out a number line and we mark it all up. It is out of 3, so for every third, 1 is a whole number. So we're starting at 0 and we're jumping to 8/3 because that is what we're given. And then we have to see what evenly divides up on the inside. So 1, 2, 3, 4, 5, 6, 7, 8. 4 and 2 can be split up. So if you jump 4 times all the way to 8/3, you'll get 2/3. So you know that 4 times 2/3 is equal 8/3. Since these are split up on the inside, 4 times 2/3 is 8/3. So you'll start off with 0, jump 4 times 2/3, which gives us 8/3. So another example is the number line. We have -3 times 5, 6 equals to -15/6. I wrote that out. -3/1 times 5, 6 is equal to -15/6. I wrote everything out. Starting at 0, we're going to the left because everything is negative. We're jumping -3 times 5 spots. So 3 times 5 spots because it's already in 6, so we don't have to say 5, 6 to confuse everything. So starting at 0, we're jumping -3 times. We're jumping 3 times. 5 spots. So 1, 2, 3, 4, 5. 1, 1, 2, 3, 4, 5. 2, 1, 2, 3, 4, 5. 3. Jump 3 times. The arrow still goes to 0. But that gives us negative 15, 6, which is what they said the answer would be. Okay, so multiplication of a fraction by a fraction. Here we have 7 over 4 times 3. Since we don't have to worry about the denominators, even though we know that that is over 1, we can just say 7 times 3 is 21 over 4, because that is the answer and that is what it is. So here, drawn out, we have 3 times 2. So we're going up 2 spots, and we're going to the right 3 times. 3 spots. So filling all of that in, that is shaded in, that gives us 6 spots shaded in. That is an example on how we represent 3 times 2 being 6. That is also called the area of something if we're multiplying the width and the height. So moving on with some more examples of multiplication, we're going to go ahead and do these. So going across, 4 times 2 is 8, and 3 times 5 is 15. That can't be simplified, so that leaves us with 8/15 as our final answer. Here we have 5 times 2, which is 10. And then 8 times 3, which is 24. 10 over 24 is the answer, but can be simplified. So you divide that by 2 over 2, and you'll get 5/12, which can no longer be simplified, which will be the answer. So here we're multiplying 2 mixed numbers. We have 3 and 1/7 times 5 and 1/4. It will be easier just to go ahead and make these improper fractions, so we can multiply them and be done. So multiplying 7 times 3 is 21. Add 1 is 22 over 7 because the denominator never changed. 4 times 5 is 20 plus 1 is 21 over 4 because the denominators don't change. And then we multiply those. So this can also be simplified and rewritten as 11 times 3 over 2 times 1. That is equal to 33 halves, which is equal to 16 and 1/2 formed into a mixed number. You can also just go ahead and multiply 22 times 21, then get that answer, divide 7 times 4 by it, and that will give you like 16.5 in the calculator, which you also know is 16 halves. Okay, so now we're moving on to the division of fractions. Consider that the division problem is 4 over 3 divided by 1/6. So we ask ourselves, how many 1/6 are in 4/3? So since 4/3 is equal to 8/6, since 6 is the denominator here, we can make it to 6, 8/6, and 8 is equal to 8 and 1/6. That leaves 8/1/6 going in there. So here we can multiply that out. 4 over 3 times 6 over 1. If you don't think you did this right, we just do this. 4 over 3 times 6 over 1. And it's because the problem was 4 over 3 divided by 1/6. But remember, we said we multiplied by the reciprocal of the second fraction. So that will be flipped, the inverse of it. So then we'll have 24 over 3. And 24 goes in, 3 goes into 24 8 times, which leaves us with the answer of 8. Okay, so another problem. We have 7/12 divided by 1/6. So we're asking again, how many 1/6 are in 7/12? So you have 7/12, which is equal to 7 over 2 times 6. So you split that up, you have 7 halves times 1/6. That leaves us 7 halves because we're canceling out the 1/6 because we're asking how many 1/6 are in that 7 halves from the beginning. So that is 7 halves. Or you can just do 7 halves times 6 over 1, multiplying by that reciprocal. You'll get 42 over 12. And you're simplifying that, so dividing by 6 over 6, that will also leave you with 7 halves. Okay, so the division is an inverse operation of multiplication, division of fractions. Let A over B equal C over D. Be fractions when C over D is not 0, then A over B divided by C over D equals M over N if and only if A over B equals M over N times C over D. And I know that is confusing, but we will talk about that in just a second. Okay, so now we're going to talk about algorithms for calculating the division of fractions. So here we have division by finding common numerators. Okay. So let's say we have 4 over 3 divided by 5 over 2. If we find common numerators, which will be 20, because that is the least common multiple, 20 over 15, because you're multiplying that by 5 over 5. And then here you'll multiply this by 4 over 4, which will give you 20 over 8. So taking from the second fraction, making their denominator as the numerator, and from the first fraction, making that denominator as the denominator, that will leave us with the answer 8 over 15. So moving down to division by finding common denominators, it is the same thing. We're doing 7 over 12 divided by 1 over 6. Finding common denominators, which is 12, we have 7 over 12 divided by 2 twelfths, because we're multiplying this by 2 over 2 to get 2 twelfths. And that will leave you with 7 halves. And instead of using the second fraction as the numerator, we're using the first fraction as the numerator here. So with the denominators will be the first fraction, with the numerators will be the second fraction as the numerator. Okay, so now you should be somewhat used to division by the invert multiplication rule, because that's what I've been using the whole time. So we have 5 halves divided by 3 fourths. Now we need to multiply 5 halves by the reciprocal of 3 fourths to get the answer. So 5 halves multiplied by the reciprocal of 3 fourths, which is 4 thirds. So any reciprocal of a fraction is just flipped. That gives us 20 over 6, which is also equal to 10 thirds. And to put that in mixed form, it will be 3 and 1/3. You know, to get that in mixed form, you just divide it. So 3 goes into 10 9 times. 9 times 3 is 3. 9 times 3 is 9. Subtract that is 1. So that'll be 3 and 1/3. And 3 goes into 10 3 times, actually, not 9. So 3 times 3 is 9. Subtract that, that'll be 3 and 1/3. So what the remainder is will be the numerator. The denominator is always going to be what is divided by into that. Okay, so I just showed you the examples, so now I'm going to tell you what those examples were saying. It was saying for the division by finding common numerators that a over b divided by a over c is equal to c over b. So notice that a over b is equal to a over c times c over b. For division by common denominators, it is a over b divided by c over b is equal to a over c. So notice how a over b is equal to c over b times a over c. And for division by invert and multiplying rule, you have a over b divided by c over d is equal to a over b. So now a over b times a over c, where c over d is inverted and becomes d over c, multiplied by a over b formula, which is a over b times d over c times c over d equals ADC over BCD equals A over B. And these are the exact same thing I just showed y'all before with the example using actual fractions and numbers. Okay, last but not least, we're going to do some samples and examples with division of fractions. So first we have 3 over 4 divided by 1/8. So my main go-to is the invert and multiplying rule. So that is probably what I'm going to do with all of these, but you can do whatever one you want. That is just personally what I choose to do. So 3 over 4 divided by 1/8. So that will be 3 over 4 times 8 over 1, which gives us 24 over 4, which gives us 6 as the final answer. So now we have 2 over 5 divided by 2/3. So that gives us 2 over 5 times 3 halves, which is 6 over 10. And that can be simplified, divided by 2 over 2, which gives us 3/5 as our final answer. Here we have 3 divided by 4/3. So any number over 1 is itself. So 3 over 1 times 3 over 4, because that is reciprocal of 4/3, is equal to 3 times 3 is 9. 4 times 1 is 4, and that can't be simplified, so that would be our final answer. Here we have 39 divided by 13. We can put both of those over 1, which equals 39 over 13, and that will give us 3 simplified. And here we have the same numbers, but they're swapped. So that is 13 over 1 times 1 over 39, which is 13 over 39, which is 1/3. Simplify. And then here we have 4 1/6 divided by 2 1/3. So we do what I said and make these improper fractions to make everything easier. So that would give us, multiply that, 25 over 6 times, multiply that, 6, 7, that'll be 7/3, but since we're multiplying by the reciprocal, that will be multiplied by 3, 7. And so then we just multiply 25 times 3 and 6 times 7. 25 times 3 is 75, of course. And 6 times 7 is 42. And that could be simplified, divided by 3 over 3, which will give us 25/14 as our final answer. At the bottom, we already talked about reciprocal fractions a lot, but here's a little more to explain, go into depth and explain. We have reciprocal fractions. The invert and multiplying rule is what multiplies by the second fraction's reciprocal. So the invert and multiplying rule multiplies the second fraction by the reciprocal. Example, C over D is equal to D over C. That is reciprocal. So you have C over D, you're about to multiply that. You're dividing by C over D, but you're multiplying by D over C. And then an actual example with the numbers is 3 divided by 8. So you have 3 over 1, because that is 3, divided by 8 over 1, because that is 8. But you're going to multiply by the reciprocal, which will be 1 over 8. So 3 over 1 times 1 over 8, which gives you 3/8 as your final answer. So that is an example on reciprocals.